Evet, hepiniz tekrar hoş geldiniz.
Welcome
Şimdi
back again.
Playable
In
Factory'nin
this
yöneticileri Kaan Özçelik
session,
ve
we will
Talha
hear
bizlerle
Talha
birlikte.
Özdemir and Kaan
Kendileri ise
Özçelik.
web tabanlı 3 boyutlu oyunları
Well, they will
geliştirmek için
talk about
JavaScript kullanıyor. Indieway
JavaScript
oyun
usage
geliştirme için bilinen programlar.
and
Web
also
ve
the
PHP
tools and the
dillerinde
concepts that are
kullanılıyor.
fundamental
Ayrıca
in
HTML5
HTML5 games.
oyun geliştirirken en çok kullanılan
The
phaser
most
kavramları ve
phaser concepts
parametrelere de dikkat
and the
edilecek.
tools
Kendilerden
are going to be
Talha
elaborated
kendilerini
by our
tanıştıracak.
distinguished speakers. I'd like to invite them all.
Ee, Gözüküyor mu sunum halinde?
Evet, görebiliyoruz.
Süper. Kısaca web
Okay,
üzerinde
so uh, I will be talking about 3D game creation for web fundamentals, concepts, shaders, and tools. So I would like to briefly talk about myself. My native language is not Turkish, and I'm a graduate of Sabancı University, Computer Science and Engineering. I'm attending a master's degree education in Bosphorus University. In the past, I used to work in the cybersecurity and enterprise software, and especially when it comes to cryptography, assembly, antivirus programs. And now I am working as a game developer in Playable Factory, and since 17 I've been writing computer games on PC, iOS, whatever actually. So am I audible, by the way, clearly?
Evet, duyabiliyoruz.
Yes, you are.
Duyabiliyoruz.
Yes, we can hear you. Okay. Anybody who would like to ask a question, they can do so. Well, so the core thing that you have to do is to, first of all, create a prototype. But the tools that you select are really important because web-based 3D rendering, different from 2D, is resource-based. When you are dependent on a device and in the engine, the particle systems may not function properly, it wouldn't have a physical engine. So either you have to do an addition or else you have to select the tools appropriately and prepare your project accordingly. And our third stage is to finalize, and then you polish it, the prototype. And finally, maybe the second most important thing is to export it and test it, because web-based 3D game development compared to conventional PC or else different from console game, you kind of follow many devices. Web page, it has to be mobile phone operable, and it is good. The resolution is really extreme on mobile, and it has to also operate on tablet and on PC, on Mac. It has to operate on all those devices, or else that is what is being targeted. So at least we have to take into account certain things. So I would like to show you some exemplary games. Is my browser still seen? Yes, okay. So within 7 days, actually, this is a game that we have written, we have designed. All our games are with a single developer. That's what, or the core code, everything belongs to me. And here, as you see, there is this simple 3D game. We've got the fog effect here, and we've got the UI around, and in the control, it is really intuitive. It is similar to the original of the game. This is a playable app, of course. And it is close to the original game. That is our target. And also, we want to not to sacrifice and compromise on visuality. And this is another game. Let me just refresh the page. And here, this has been also designed within 7 to 8 days. Well, here, the interesting thing is that underneath the keyboard is not a native keyboard. Well, we are not able to access the native of the device, and we have to write it ourselves. We have done it with the phaser. So Talha, just like he has explained, there is this framework which is operating in the forefront, and in the background there is the game, and we don't have any game engines. And as we don't have any game engines, everything is on hardware, just like with the render. You first of all create a model and lighting and also the angle of the camera. You have to script write all the animations, everything. I mean, there isn't a core game engine underneath, but I would like to show you more beautiful alternatives for a person who's interested. Here, I was going to explain about the constraints, what kind of problems you may face. Well, each device render capacity is not the same. For instance, for mobile phone, the screen card and PC screen card do not operate in the same capacity. So for that reason, CSGO, WebGL, you cannot operate it as a WebGL application because the rendering techniques there are not the same as the mobile phone render techniques. And even though we code it, we wouldn't expect it to operate properly. And it has got a higher structure than hardware. So hardware and web-based do not speak directly to each other. There should be a browser or as an interpreter kind of thing in between. That's why we shouldn't expect the code to operate properly. And JavaScript code, I mean, there is an execution difference between the two, because there has to be an interpreting software in between these two renderings, and there could be a problem with media compatibility, media format compatibility. In 21st century, this is not a problem, but for instance, MP4, I mean, if this software is in 1990s, it cannot maybe render a certain model. So backwards compatibility is really important when it comes to 3D game and web-based gaming and game design. And we may not be able to achieve certain effects and with the due to engine and renderers. And load time and optimization is one of the most critical things. Why? Because once you develop a web-based game, if the upload takes 30 minutes, nobody would play that game. You have to immediately upload it on the application. Either the file sizes should be relatively small, or else there should be a proper uploader. And also there are two exemplary tools, Godot, for instance. I'm sure that you've heard about the Godot engine. It's a good engine. This is one of the best game engines that I like, which is available on the market. And it has got the future to have a prototype 2D and 3D game, and we can export it. And C#, it is got it is easy to learn the language, and Unity is more export file size is a bit higher. That's why for web, it is not fully optimized for web. But of course, we can get the export and we can actually transfer it to whatever platform that we want. Play Canvas, it is interesting. This is a new engine which has been launched. Well, it is based on WebGL and it has got an online web editor. It doesn't have a local web editor. So when preparing a game, it is interesting, but it has got a relatively easy to understand system. But I think that it is based on a monetary subscription, and 3GS is primarily what we use. Actually, GS is only a render. It is not an engine. It is to move certain visuals and to add shaders. This is a WebGL interface. It is the more valued version of WebGL. And the disadvantage of it is that if you start writing a game, you have to do everything manually, the camera following the gamers, and an object going from A to B. I mean, even the importing of the model, you have to write it yourselves. Of course, there are plenty of examples when you log on to the website of FreeGS, but as an example, Cranker, for instance, is given. Let me, maybe you've heard about it. Let me just log on. This is the multiplayer CSGO type game. Of course, it is completely written with 3GS. And the network coding in the background has been prepared by using different libraries and different interfaces. So why develop 3D games for the web? Because we've got apps, we've got softwares, and I mean, why What is the disadvantage? Well, the answer is really simple: publicity and ease of access. Well, most of our listeners would have an internal account, or else indie game developers they are. So your game, if I mean, convincing a person to download your game is difficult because you've got a huge market around you and you've got a huge R&D around you. But if you upload it with a WebAssembly format, once somebody logs onto your website, he has the possibility to log on to your game, and the number of users that you access becomes much higher. So in terms of publicity, it is much logical to compile it on web, your games. And it could be a client-specific software. For instance, you receive a customer, for instance, BMW, and wants to offer its new car, and on a 3D base, they want the car color to be changed, and 3D engine, a 3D render is important. That could have a web-based export. And finally is the ease of profitability. From A platform to B platform, for instance, you prepare a game and you want to switch from A platform to B platform. You want to switch it to a Mac OS. And if inherently it operates on web base, it could operate on any device. And of course, there could be a loss on performance, but it would operate on all devices, and the number of net users that it accesses becomes higher. By using a container program, for instance, you can package it and port it to anybody, to all platforms indeed. And finally, shaders. I would like to talk about shaders. What is a shader? I'm sure that you've heard about it. It's like a black magics to some, but shaders are codes that are added on renders for the screen card, or else for GP. It's a special code which is written for graphics. It has got a language similar to C, and if you're using a Godot engine, it has got its own shader language. Unity has got its own shader syntax. There may be variations, but the core, they do the same. And they compile on the same code, most probably, because there are not many variations between screen cards. And if you want to achieve good visual effects, if you want to, like, for instance, here you have the whole shaders. And you have a more cartoon-like graphics, and you have to have a special shader code for that. And there are two shaders. One is vertex, the other one is fragment. Vertex shader only does color operation, or for all the pixel on the screen, or as for all the dot on the material, a color is calculated, and it has got an input value and output value, and the output value is only a color, RGB and alpha base. And for all pixel, there is a code which is operating, and vertex shader, on the other hand, is for all vertices on the model. Each triangle tip has a code operating, which means, for instance, you've got a cube, and just this cube, you want to give a jelly-like effect when it drops on the ground, as it becomes like a gel, for instance, or as a rubber ball that hits the ground. And you want to give that effect, and vertex shaders, like you feed in the falling speed and the touching ground, and you could create a jelly effect. For instance, a cube, for instance, you could turn it into different shapes. So if the model shape changes, vertex changer, and the other one, it changes the color. And all core have shaders. It's impossible for you to have a large-scale game without any shaders. From the grass on the ground, the trees moving, and the light rays even, they operate with the shaders. This is all from me. Here you've got my contact info. If you've got any questions, you can pose them, of course.
Şu an soru gözükmüyor.
We don't seem to have any questions, but if you want to have any further remarks, Taha, this also goes for you. You can come up with your final remarks, anything that you would like to add, Joe, because we've got an extra 7 minutes. Superb. I mean, yeah. We were able to finish off on time, I guess. So I don't have any further remarks, but my friends here can also get in touch with me. I'm eager to help. Yes, you've got our contact info. I'm sure that if you have to write something application specific to a client at the end of the day, or else if you want to port your game to a different platform, you will definitely need a web development in that sense.
Evet, sorumuz yoksa o zaman ben
If you don't have any
teşekkür
questions,
ederim
I would like to
sunduğunuz
thank
için.
to both of you for your participation, for the information that you have shared. We thank you indeed. We
Tekrar
thank you.
teşekkürler, görüşmek üzere.
Have a nice day. Hope to see you. Bye bye.